So to find out the reactions at point A, first we will use the moment equation, which is summation of moment by all the forces about the point A is equal to 0. Okay. So moment by VA and moment by HA will be directly 0 because both these forces, they are passing through this point. That is a moment point. So there is no perpendicular distance. After this, we have one point force or point load 6 kilonewton. Its distance is 1.5. So this is the moment 6 into 1.5 and it is clockwise. So it is negative. Next, we have the force 4 kilonewton, but it is inclined. So we have resolved the force along X and along Y direction. Now just consider the X component, which is the 4 cos 30, and take the moment by this force about the point A. So for that, we need perpendicular distance from the point A. So it is not given directly. So what is given? 3 meter, and this inclined distance 1.5 meter. Okay. So from this, we will find out the perpendicular distance. So here you can observe in the second diagram. So this is your complete beam AB. Okay. This is the force or point of application of force 4 cos 30. For the perpendicular distance, just extend this line of action like this. Okay. So I have drawn here dotted line. So this is the line of action for the force. Now on this line of action, from the point A, if you draw the perpendicular, then this will be the perpendicular distance. Okay. So this is the force and this is the perpendicular distance. So we can write the moment equation, but this distance is not given directly. So how we can find out? So observe this 1.5 meter. From point C up to point B, distance is 1.5. This angle is 30 degrees. So if you construct the right angle triangle here, so this side, this is nothing but the perpendicular distance. So you can find out this by using this triangle. It is 1.5 sine 30. So this is 1.5 sine 30. This is the perpendicular distance. So write the equation 4 cos 30 is the force and distance is 1.5 sine 30. Okay. Now this moment, this will be clockwise. Okay. Just imagine instead of point B, the same force, it acts at the point or at this point. Let us take this point as a M. So this force, it will rotate the given system in the clockwise direction like this, and therefore this moment is negative. Next, consider 4 sine 30. Okay, so 4 sine 30, so this is the 4 sine 30. So for this force, your total perpendicular distance will be from the point A. If you draw the perpendicular, so this total distance, this is the perpendicular distance. Okay, so here we have 3 meter, 1.5 plus 1.5, and plus we have to add this distance. Let us take this point as a n. So distance Cn. So this distance, this is equal to 1.5 and this is 30. So it is a cos 30 because this is Cn is the adjacent side and Vn is the opposite side. Okay. So your moment will be, component is 4, this component 4 sine 30. Okay. And the distance is 3 plus, so it is 3 plus 1.5 cos 30. Okay, so this is total moment value. This is the force component and this is the distance. Now observe the direction of rotation. So this force, it will rotate the complete beam again in the clockwise direction. Okay, and therefore it is negative. So after this, observe this moment ma. This is the moment reaction and it is in the anti-clockwise direction. So add this moment plus ma and then equate this to 0. This is the condition of equilibrium, summation of moments. Now solve this equation and get the value of ma. Okay, so try to find out this. You can give the answer in the chat box. Okay, so check the answer. Ma is plus 20.19 kilonewton meter So we get the positive answer after solving this equation. That means our assumed direction is correct. MA is acting in the anti-clockwise direction only. Okay, so show this direction anti-clockwise. So this is the first unknown. After this, use the equation summation fx0. Okay, so for summation fx0, we have HA on the positive side, which is the unknown. Next force is 4 cos 30. Okay, so this is also in the positive direction. So plus 4 cos 30, and there is no other force in the x direction. So this is equal to 0. So from this we will get HA. This is equal to minus 4 cos 30. So your HA value, it is 3.46 minus 3.46 kilonewton. Okay. So as the HA is negative, that means our assumed direction is wrong. So we can write this HA. This is equal to 3.46 kilonewton, and this is the correct direction. So it is acting in the negative x direction. Okay. And after this, use summation Fy0. So for summation Fy, we have Va in the positive y direction. After this, 6 kilonewton in the negative y direction, so minus 6. Then we have y component 4 sine 30. So it is also negative, minus 4 sine 30. And there is no other force in the y direction. So this is equal to 0. And from this, calculate the Va. So Va is equal to, so this is equal to 8 kilonewton. And we get the positive answer. That means our assumed direction is correct. So Va, it is acting in the positive y direction only. Okay. So in this way, we can find out the unknown reactions at point A. Okay, so refer this problem, which is the fifth problem in the assignment. So what is given in this problem? The oil rig, which is shown above, has mass 2400 kg and center of mass is G. Okay, so this is the center of gravity. If the rig is pin connected, so meaning of pin connected is this is the hinge support at its base. So here you can see this is the pin connected. So this is your hinge point. Then determine the tension in the hoisting cable and the magnitude of the resultant reaction at the base A when the complete rig is in equilibrium. Okay. So here your first step is you should draw the free body diagram. So I will just show how to draw the free body diagram and you can complete the remaining calculation. So in the free body diagram, you have to draw this rig as it is. Okay. So this is the rig. Then at point A, so this is the point A, which is the hinge point. So at the hinge point, when we separate this beam or the rig from its support, we have to show the support reactions. So this is the vertical reaction at point A, and this is the horizontal reaction. So this is a HA. Okay. Then at this point, it is cable connected. Okay, and this cable is passing over this smooth pulley. So if you cut this cable like this, then we have to show the tension. So this is the tension force. So it is directed away from this point. So just assume this point to be P and this point is Q. So this direction is away from this point, and similarly for the point Q. So these are the two tension forces at the point P and at point Q. So here we have the point P. So this is your point P and this is the point Q. Okay. So this is the tension force. This is T. And it is the same tension because this complete part, it is the single cable. Okay. Therefore, if you cut the cable like this, both its part will have the same tension. So this is T and this is T. Okay, so after this, at this center of gravity, which is the point G, the complete weight 2400, okay, it will act in the downward direction. Because for any object, if you take any object, which is a rigid object, then its total weight, it acts in the downward direction from its center of gravity only. So this is the W, okay. So similarly here, this is the center of gravity. So the weight of the object or weight of that oil rig, it will act in the downward direction. So this is a W, and here W is equal to, so actually mass is given, okay, which is 2400 multiplied by 9.81, you will get the weight. This is in Newton. So consider this value W here at the center of gravity. And there is no other force. And just mention the distance. So here we have 5 meters from this point P up to the point Q. Then from P to G, it is 3 meters. From G to A, this is 10 meters. Okay. And here, so from this A point, this distance, so consider this point to be N. A to N distance is given as a 1.25. So why that distance is given? So that 1.25 distance we need to consider while taking the moment by this tension, okay, about the point A. So because one component of this tension, it will act in this direction, that is in the horizontal direction. And by taking the moment by that horizontal component, we have to consider this 1.25. So I will show that component. So actually we should resolve that tension T. So this angle is given 60 degree. So this is the X component and this is the Y component, okay, and this angle is 60 degree. So this X component is T cos 60, Y component is T sin 60. Similarly, resolve this tension at the point P. So this is the X component and this is the Y component, but here angle is not directly given. So observe this. Okay, so the angle is given in terms of distance. So this is 3 and this is 4. Okay, so this is the angle. Let us take this alpha. So alpha is equal to tan inverse. This is 3 by 4. So this component will be, so this is alpha. So this is sine component. So it is a T sine alpha. And this is T cos alpha. Okay. So there is no other force which is inclined with the X or Y axis. So only two forces, that is the tension forces at point Q and P. Okay, so this is your complete free body diagram. Okay, so after this, just use summation of moment by all the forces about A, this is equal to 0. So by using this equation, you will directly find out the tension. Okay, because W is known, which is this value. And then to find out these reactions, VA and HA at the hinge support, use summation Fx0 and summation FYZ. Okay, so this is just an calculation. Important is free body diagram. So if you draw correct free body diagram, then you will get the correct answer for the reaction.